This video is going to talk about single replacement and how to predict the products, okay? So taking a look at single replacement notes, go ahead and remember that single replacement is where we are taking an element and it's going to replace that element that's like it in a compound. So one reactant must be an element and the other one must be a compound. The products will be now a new element and a new compound that's been formed by the rearrangement, okay? So I do need you to remember a couple of oxidation states of transition metals that are always what they are, even though they're transition metals. So zinc, for example, is always going to be +2, and silver is always going to be +1. So neither of these actually need Roman numerals, even though they're both in the D block and both transition metals. These often come up in our single replacement reaction, so I want you to know those. So there's another resource you're going to use during the single replacement predictions, and that's your activity series. We talked about this a little bit briefly before the midterm. So the activity series is on page 7 of your chemistry reference table packet. Remember, a higher element or a more active element replaces things lower on the activity series. If the element by itself is lower on the list, then the reaction does not occur. So let's look at some examples. You do have your recipes like we had for the other reactions. So here we have a metal-metal replacement. So this means a metal will replace a metal. So this would be a metal and it would be replacing the metal in the compound to form a new metal compound, or metal with non-metal compound, and then it will kick out a metal. Then we have an active metal replacing a hydrogen from water. So you'll have a metal and it's going to replace the hydrogen inside of the water to form a metal hydroxide and hydrogen. This is what you're going to have to see is that the metal will have to be higher than H on the activity series. Next, you have an active metal replacing hydrogen from an acid. So you'll have a metal with a hydrogen acid compound. So it'll always start with H because it's an acid. And that metal will replace the hydrogen. Again, it's got to be higher than hydrogen on the activity series. And it'll form your metal with whatever else was a part of the acid with H2. And then last but not least, you have a halide or halogen replacing a halogen. So you'll have something like chlorine or fluorine or bromine or iodine here, and it will replace something like it, another halogen over here. So you'll end up with that halogen that got kicked out by itself. Don't forget Brinkelhoff, and a new compound with the other halogen that came in. So let's put that to some concrete examples. So we have potassium and sodium chlorine here, or sodium chloride. So if we take potassium and we look at sodium chloride, we see that potassium is like sodium. So potassium will replace the sodium in the compound. So when we do this, we check and see, is potassium higher than sodium? It is according to the activity series, and so we can predict our products. So because it's higher, this occurs. So our potassium kicks out the sodium. So see how sodium is by itself. And now we have potassium chloride together. And so we now have a compound. Don't forget to swap and drop. And so remember that you have to check that this has been swapped and dropped. So +1, -1, turns out we're okay. Okay. We also should last check for balancing. In this case, it's already balanced. Okay. So let's try one more. Let's see if 10 could replace something in this compound. So if we look at this, 10SN is actually like it's a metal. So it's going to replace the metal in the compound. So that's iron. So can 10 replace iron? So we ask ourselves if it replaces it, can it, according to the reference table? Turns out that it's not. So we actually get to write no reaction occurs. Okay. So this does not occur. Make sense? So if you keep going through, you can see a few more of these examples and see how, for example, this one is sodium trying to replace hydrogen. So if we think of water as HOH, it's trying to replace this first hydrogen. So this example, what happens is sodium is higher than the hydrogen. So if we do this, we can show that sodium now bonds with the hydroxide. Hydrogen gets kicked out, but we remember we got to include our diatomic. So it's H2, okay? Don't forget to swap and drop, +1, -1, we're good to go, okay? So take a look through these and see if you can figure out the rest of the recipes for single replacement. But again, you're following on page 6 along with page 6 and figuring out how to replace them.